Okay, Terry, please tell me the tangent of 30 degrees. Very good. Root 3 over 3. So if you can find the tangent of 30 degrees, you can find the tangent of 150 degrees. The only thing that might change is the sign, the sign. Okay? And then, Terry, in the second quadrant, is tangent positive or negative? It's negative. Therefore, the tangent of 150 degrees is? Negative. Root 3 over 3. Okay. Any questions there? Okay. Show on. Please tell me, what is the cosecant of 30 degrees? The cosecant of 30 degrees is 2. Now tell me, in the second quadrant, is cosecant positive or negative? Positive. Therefore, the cosecant of 150 degrees is? Very good. Nikki S., please tell us the secant of 30 degrees. The secant of 30 degrees will not be negative. Very good. Nikki S., is secant positive or negative in the second quadrant? Negative. So the secant of 150 degrees is? Very good. Yes.
We're basically just flipping everything, right?
Not everything. Notice that 2 of them are positive and 4 of them are negative.
Well, yeah, but not looking at like positives or negatives, just the numbers. They're all the opposite. And then when it's a radical at the bottom, you just have to fix that, right?
What do you mean by the opposite?
Like, opposite of 1/2 is 2.
Oh, the reciprocal.
Opposite of radical 3 over 2 is 2.
Yeah.
Radical 3 over 3 because...
So for you and everyone else, in math, opposite means something very specific. That's why I was confused. Opposite sign, sorry. Reciprocal means 1 over the number. And then inverse means undo the operation. So back to your question. You can absolutely use your knowledge of reciprocals to find cosecant, secant, and cotangent. You're right. To find cosecant, for example, you just flip sine's fraction. To find secant, you can just flip cosine's fraction. And then Nikki B., why don't you just tell us what is cotangent then?
It would be 3 over radical 3, and then you would change it. So it would be 3 radical 3 over 3. So then it would just be 1.
That's true?
1/3. Well, no. It would just be radical 3.
Radical 3. Okay, therefore the cotangent is going to be negative radical 3. Good. I'm really glad you made that connection. Use all of your knowledge and understanding to help you with any given problem. Any questions on example 2? Great. Dominique, 300 degrees. What quadrant will the terminal side be in, please? Very good. The fourth one. And Nikki B., what will the reference angle be for 300 degrees? 60. Very good. It still has to do with a right triangle. In this case, a 30, 60, 90. Sorry, I did a poor job of drawing that to scale. Gabe, the side opposite of 60 will be
Radical 3.
radical 3. The side opposite 30 will be
X.
x, or 1. And the hypotenuse will be 2. As I've said before, what I have noticed some students do is include the negative signs in the side lengths. Yes, I know side lengths cannot be negative, but it helps to get to the answer for some people. So the y coordinate is going to be negative. So what some people like to do is to make that negative root 3. The hypotenuse will always be positive. It's kind of by definition. And then the x coordinates are positive here, so we can leave that as positive 1. Good. Nick, sine of 300 degrees. Negative root 3 over 2. Very good. Okay, negative root 3 over 2. Allie, cosine of 300 degrees. So tell me what you know about cosine. Very good. So your adjacent side here is 1, and your hypotenuse is 2. 1 over 2. Good. Sue, tangent of 300 degrees? Negative root 3. Question.
Why is the 2 not negative right now?
The hypotenuse or the radius will always be positive. I could say by definition, but I'll try to give you a better answer than that. And here it is. We're going to work more on the coordinate plane. So here's a point on the coordinate plane, and the terminal side of an angle goes through that point. This is trigonometry, so we're working with triangles. Right now we're in right triangle trigonometry land, so we are working with right triangles. So if you drop an altitude, form a right angle. This is going to be y. This is going to be x. Hopefully that makes sense to you. That if the coordinates here are x, y, then this is y, this is x. This is the hypotenuse. You use Pythagorean theorem to find it. Let's call it r. So r squared equals x squared plus y squared. In other words, r equals the square root of x squared plus y squared. If x is negative or if y is negative, it doesn't matter because you're squaring them. Therefore, you're always going to get a positive answer here. So that's the best I can give you right now. Brett, tell us, cosecant 300 degrees.
2.3.
Except it's negative.
I have a question.
Yes.
I don't really understand how you're getting positives and negatives and where's that?
Okay. There's 2 answers I can give you. One has to do with the coordinate definitions of the trig functions. So, for example, sine, by definition, is y over r. That's why I had you make those drawings. Using Descartes' system, in the 3rd and 4th quadrant, the y coordinates are negative.
Always.
Always. Therefore, in those quadrants, sine will be negative.
But I just, like, I don't get that. How is one triangle the sine positive and one triangle negative if the y sine is always negative?
So you misunderstood me. In the third and fourth quadrant only, the y-coordinates are negative. Therefore, in the third and fourth quadrant only, sine is negative.
And it's in the third and fourth by like 300 instead of 4.
Exactly.
Okay.
Okay? You can also use the ASTC mnemonic device. All students take calculus.
All Santa Claus.
All are positive. Sine and its reciprocal are positive. Tangent and its reciprocal are positive. Cosine and its reciprocal are positive. Good. Excellent question. Sue, again, tell us the secant of 300 degrees. It's going to be positive because you're in the fourth quadrant. If cosine is positive, then secant has to be positive. Dominique, cotan?
√3/3.
But it's negative.
Okay.
Okay. It's very important that you include the negative sign if it is applicable. Any questions on example 3? Okay, again, help each other as much as possible. Example 4. Celine, 135 degrees. What quadrant will the terminal side be? Very good, second quad. And second question for you, Celine, what will the reference angle be? Very good. And we'll continue with you. Can you label this side for me? This one? This one? Good. And then some students might want to put a negative in front of this one, since you're in negative x territory. Do what works for you. Thank you, Celine. Nick, sine of 135 degrees. √2/2. Very good. Amber, cosine of 135. Excuse me.
Negative √2/2.
Negative √2/2. Very good. Sue, tangent of 135 degrees. -1. Good. Jessica, cosecant of 135 degrees. Positive √2. Good. Val, secant of 135 degrees. Negative √2. Good. Gabe, cotangent of 135 degrees.
-1.
-1. Okay. We good? You especially? Okay. Moving on. Celine, reference angle for 57 degrees. 57 degrees. If it's in the first quadrant, no need to compute anything. Terry, reference angle for 158 degrees. 22 degrees. Yep. 180 minus 158. Brett, reference angle for 263.4 degrees. Say again? B? Yes. So know how to find reference angles. Jessica, reference angle for negative 15.9 degrees. It's A. You know, I think of things sometimes when I wake up in the morning or on my drive to and from work. Here's something I thought about. Ask yourself, how far am I away from the x-axis? That's what all these questions are asking. Negative 15.9 degrees is here. Reference angles, though, are always positive, and with respect to the x-axis. So the reference angle is just positive because you're 15.9 degrees away from the x-axis. Absolute value, you got it, my man. Nikki B, reference angle for 380 degrees. Yes. It's 20 degrees away from the x-axis. Hopefully you have now sufficient practice with reference angles. Any questions, though? Notice that you're using 180 or 360, never 270 or 90. Okay, Nikki S, tangent of 60 degrees. Say it louder. D? No. So let's do this one. $30, $60, $90. Nikki S, help me label.
Oh, is it just C radical 3?
Do you understand why?
Yeah, because I did the hypotenuse third.
Okay. Dan, cosecant of 30 degrees. Two, very good. It's the reciprocal of sine. Sine of 30 is a half. Cosecant of 30 is 2. Nick, sine of 210. D. Yep. You may be wondering how I'm doing these in my head. I will explain to you. First, I look at the angle. I figure out what quadrant it's in. I can do that in my head. 210 is above 180, therefore it's in the third quadrant, and it's less than 270. Then I think, sine, is that positive or negative in the third quadrant? It's negative, so my answer is negative. That eliminates choice A, choice B. Then I calculate the reference angle in my head. 210 minus 180 is 30. Then I ask myself, what is the sine of 30 degrees? I can usually visualize the 30, 60, 90 in my head. The side opposite of 30 is 1, or x, and the hypotenuse is 2, or 2x. So 1 to 2, and it's just negative. Okay? And you can get there as well. I was an average math student. Please don't think that I have some special abilities. I even failed a math class. So if I can do it, you can. Okay.
What class did you fail?
Differential equations. Calculus 4. Amber,
Yeah.
cosine of 150.
Radical 3 over 2.
Radical 3 over 2.
Negative radical 3 over 2.
It'll be negative.
Yeah.
Yeah, because you're to the left of the y-axis. And the reference angle is 30 degrees, and the cosine of 30 is root 3 over 2. So it's negative root 3 over 2. Chowan, tangent of 300 degrees. Negative radical 3? Yep. Okay. Draw your right triangles. Draw your coordinate plane. Do whatever it takes. Dominique, cotan of 120. Agreed. Okay. Anyone need me to go over 6 through 11? It's essential that you be able to find those trig function values without using a calculator, just like you did for the 2-1 quiz. Okay. Now we're using our knowledge from like the previous part to basically answer a slightly more advanced question, but it's not too difficult. So Nikki S., please tell me first, what's the cosine of 120?
It's 1 over radical 3, so it's radical 3 over 3.
What's the reference angle for 120?
60.
Yep. So you're working with a 30, 60, 90. 1, root 3, 2. We want cosine. Cosine is adjacent over hypotenuse. So the adjacent is 1. The hypotenuse is 2. Yeah, and because 120 is in the second quadrant, and because the x's are negative over here, it's negative. Okay. So negative 1/2. Val, please tell me the cosine of 30 degrees.
You smiled at me and I feel like I'm wrong.
30 degrees. Tell me the side opposite 30 degrees, Val. Okay. Tell me this side. Or x root 3. Tell me this side. Good. Tell me the definition of cosine. Good. Tell me the adjacent side. Yep, or x root 3. Tell me the hypotenuse. 2. You are correct. Okay. And Jessica, tell me the cosine of 150 degrees. Negative.
Okay.
Yeah, I don't have these memorized. I'm just doing it all in my head. And it's only because I've done it for thousands of hours more than you. That's it. It's a matter of effort more than anything. Now we have to ask, is negative 1/2 plus root 3 over 2 equivalent to negative root 3 over 2? No. Negative root 3 over 2 is equivalent to negative root 3 over 2.
Negative 3 over 4.
On the left?
Yeah.
No.
No, that's 1/2 times. Right?
No. It's negative 1 plus root 3 all over 2. And negative 1 plus root 3 does not equal negative root 3. Therefore, falso. Any questions on 12? What's that? Oh, yes, but wait. There's more. Let me jump to 14. Nikki B, negative 302 degrees. What quadrant is that in?
No, wait. The third. Wait. Negative? So I have to go backwards? So the second? First one.
Negative 90, negative 180, negative 270.
Okay. That's right. Okay. So the first.
Okay. Tell me, who's positive in the first quadrant?
Everyone. All of it.
Yay!
Can't be B, it can't be D.
Jen, 523. Tell me how I can figure out what quadrant it's in.
So basically, you can subtract 360.
I love that idea.
Okay, so then you can take it from there and sort of try to picture and look, starting from the usual 90 that we start with. And so it's going to be less than 180, so it's going to end like in the second.
Excellent. It's less than 180, and it's more than 90. Therefore, it has to be in the second quadrant. Jen, tell me, second quadrant, who's positive?
The y side of the y. Right.
That is true. The y coordinates are positive, but my question is, what trig functions
Oh.
are positive in the second quadrant? Remember, Santa Claus.
Oh, fine.
Yeah, and it's reciprocal. Okay? So you have cosine and tan. Negative and negative. Okay, the questions are intended to make you think.
Why was cosine opposite of?
So you're in the second quadrant.
Oh yeah, that's yeah, right. Yeah, got it.
Question? Why? Do you understand how 523 is in the second quadrant?
Yeah.
Okay. That's the S quadrant. This stands for sine. Okay. So sine is positive and its reciprocal are positive. Okay. Allie,
Oh boy. Yeah.
you can do this. We believe in you. I believe in you. I can't speak for the others. So negative 65 degrees. Tell me what quadrant.
The first one. Oh, just kidding.
I'm a kidder too.
The first one.
Guilty as
First
charged.
one. Fourth one.
Okay. Fourth quad, because you're going negative.
It was a really straight line.
You see that freehand?
That was pretty good.
Thank you for the compliment. Allie, you're in the fourth quadrant, right? Please tell me now what trig functions are positive in quad 4. It's the C quadrant, so yes. And now tell me what is cosine's reciprocal? Secant. I would just commit that to memory. Everything else is negative. So secant is going to be pos, sine is going to be neg.
Hey.
Correct.
Why is secant positive? Is reciprocal of cosine?
It is.
Oh.
Okay?